note that it will take some time and then it will finish execution. If everything goes perfectly, it means that it has installed this package properly. And now if you go to C, go, and then source, I think, no, not here, sorry. If you go to users, test, and then go to the go source folder where your go path is, and then you can see that if you go to github.com, you will note that there is this one folder which is called Kindlefire, and then it has Go keylogger in it. So it has installed this keylogger, and once you install it, you create a new project. And now I will show you how to use this program. So in order to use it, you have to follow certain conventions. So let's start with it. So the first thing you need to do is you need to create a keylogger object. So I'm going to write keylogger equals to, and then you need to use this library which we have already downloaded, which is Go keylogger. So just write keylogger, keylogger dot new keylogger. So I downloaded it twice, so I think that's why it's showing 2. Otherwise it will just show 1 if you downloaded it once. Okay, so once you have it, the next step you need to do is you need to start the timer. So to do this, just write start timer and then equals to time dot now. So you, whatever the current time is, you start there. Okay, once you have this, the next thing you need is the file where you want to store your keylogs. So I want to store my keylogs here, but you can store them anywhere. So I'm going to create a new file here. So I'm going to use os.openFile method. And then I have to specify the name of the file. So I'm going to call it keylogger.txt. You can call it anything. And the next option it requires is which mode. So I'm going to use the create and append mode. So if the file is not present, create it. If it's present, just append it. So there are 2 modes. So os.o_create or os.o_append. Or os.o_append, and then you need to give permissions 0666. You can read about these permissions in the documentation, but it's necessary to just give permissions here. Okay, once you have this, you need to, this will return the file object and then an error if it cannot create a file. Okay, once you have it, you need to now start keylogging. So what we want to do is we want to get the keys. So every time, for example, if you want to get a key, you say key and then you call keylogger dot get key, and this will return the key. So whenever you press something, this function is called get key, and it will get the key and store it in the variable called key. Next, you have to use this variable. So we can check if key is not equal to if not key. So we have to check if the key has some value or not. So if the key has some value, then we want to what we want to do is we want to read this file into the program. So we want to add this key into this file keylogger. So let's go here, and then I'm going to use file.write string, and then I have to write key.run. So I want to store this key. Since it's in a run format and it requires string, I'm going to typecast it to a string. Okay, so now we have an object which will write whatever key we enter into this file. So note that this is just for one key, and we want to keep a record continuously. So whenever user presses a key, we want to store this key into our program. Okay. Okay, and then what we want to do is we want to defer file dot close. So you want to close the file properly so we don't have any problems. Okay, so the next thing, okay, let's do it in a loop so that we can get keys continuously. So let's put it here. So okay, and then we have to put these things get key in a loop so that we get the keys continuously. So I'm going to write a infinite for loop. Okay, so what will happen is that if there is some key and if not key is not empty, then it will write this key to this file that we created. Okay, so now this process will run automatically, but what we want to do is we want to introduce some time interval here so that this loop does not run indefinitely and it does not overburden our system. So what we want to do is we want to introduce a timer, a sleep here. So what I'm going to do is I'm just going to introduce a 10 millisecond sleep period so that program sleeps for 10 milliseconds and then wakes up again. So I'm going to use 10 into time dot millisecond. So now this loop will run every 10 milliseconds and it will try to get a user key. Okay, so now we have this. The next thing we want to do is that this program is designed to run indefinitely, so we don't have any exit condition here. So if we start this program, we will be stuck, and this program will continue writing and writing, and unless there is some error, it will not stop writing. So what we want to do is we want to define an exit condition. So let's say we define an exit condition that if 10 seconds has passed while the program is running, we can stop the program. So as you know that we already have our start timer here. So when the program starts, it stores the start time of the program. The next thing we want to do is, let's say we want to run this program only for 10 seconds. So what I can do is I can write duration equals to time dot since and then start timer. Okay, so what this will do is that it will measure the time duration of this program. So for example, when program starts, whatever timer this will be, let's say it's at 3 hours and 3 hours and 5 minutes and let's say 0 seconds. And every time this loop runs, it starts updating its value of duration. So whenever, for example, after first iteration, it would be 3 hours 5 minutes 0 seconds, and then the first value would be 10 milliseconds because this loop waits for 10 milliseconds. I'm just giving an example. The actual value would be very different, but we want to say that if 10 seconds has passed, we want to stop the execution of the program. So to do this, I can say if duration is greater than 10 cross time dot seconds. So it means that if 10 seconds has passed while the program has started, we can break the loop. So whenever 10 seconds pass, the program will break and it will go out of the loop, and the keylogs will be stored in this file, which is keylogger.txt. So in next lecture, we will run this program. now I'm going to run this program, so I'm going to call it go run keylogger.go. Okay, so there is a small error because I didn't use this error, so I'm just going to ignore it, and then I'm going to run this program again, and you can see that it's now recording. And if I type something, and I'm typing now, but it's not showing anything at the moment. And now 10 seconds have passed and the program has stopped. And if you go over here, you can see that there is a file created called keylogger.txt. And if I enter it, you can see that whatever I typed was stored in this file. And then you can copy this file to your own system using the previous programs that I have already developed using the malware. And then you can use the up and download function to get this file to your system. Okay, so this is how you can get the user key logs into your own system. Welcome back everyone. In this lecture, we are going to learn about steganography. Steganography is a technique that is used to hide malicious files, for example, into an existing image or PNG or any type of file. So what steganography is basically embedded payload bytes into the image bytes. So for example, you have image bytes or a PNG file which is represented by, let's say there are certain bytes, let's say 0x11, I'm just giving an example, and 0x33, and then it carries on till end, for example 0xff. So let's suppose this is an image file or anything. Any file is just a representation of bytes. So what in steganography what we do is that we try to embed our malicious code. Let's say we have another file which contains 0x4345, whatever it is, and 0x4. Let's say we just have a file that only contains 2 bytes. It does not make sense, but I'm just giving an example. So what steganography technique basically does is that it tries to embed these bytes copy and into somewhere in the actual file. So the actual file contains the original data plus the malicious code, but the main thing about this is that this thing or this encoding is very hard to detect. So antivirus programs cannot easily detect these codings. On the front, this file or image, whatever it is, will look exactly the same, and it will have an embedded malicious code inside it, and this code will be very hard to detect, and there is no direct way of understanding or detecting it unless you read the bytes properly, which is a very difficult task. So in this section we will try to embed data into images, and then we will try to extract them and see how steganography works. Okay, see you in next lecture then. Okay, there are a lot of ways in which you can achieve steganography, but these ways can usually go out of the scope of this course because they requires extensive knowledge of background of how files work. For example, if you want to use steganography with JPEG images, it requires you to have a deep understanding of how the JPEG files are created and what their file structure is. So we won't go into the details of how these things work because it will be very extensive. So what I'm going to do in this section is I'm going to install a package which is this one, Stegify, and this package, using this package we will create embed malicious files into images and then see how these things work. So in order to install it, just go to this package on GitHub and install this package. So I'm going to copy this and then I'm going to run this in a terminal. So let's see this. So let's just paste it and press enter. And since I have already installed, so it installed pretty quickly, but for you it will take a lot of time. So go ahead and install this package. Okay, so now in this section we will try to embed our malicious file into the image file. So let's start with it. So this is mol.exe is the executable or file that we want to embed, and this is the test file or image that we will use to embed this malicious code inside. Our goal is to embed this exe in this executable, so we will use this package that we currently downloaded to achieve our objective. So we need to define three things. The first thing we need to define is a carrier file, which is the test.jpg file. This file will contain our malicious code. So let's define it as carrier file, and then we need to give the name, so it would be test.jpg. The second thing we need is a data file or malicious file, so I'm going to call it malicious file equals to, and then I need to provide the name, which would be mal.exe. Before proceeding forward, let's go to the Explorer and see the size of the file. So currently the size of this test file is 538 KB. If you go to properties, you can see that it's 537 KB and its type is JPEG. So, and next thing we need to do is we need to define the name of output file that will contain our embedded code. So let's call it encoded file, and let's name it encoded test.jpg. So now we have three files defined. So the rest is very straightforward. What we need to do is we need to call a function or use this package. So I'm going to call stack dot, and then I need to use the method called encode file names. So this function will encode these files or this malicious code into this carrier file. And if you go to the documentation, you can see that it requires three strings: carrier file, data file, and result file. So we will give these files in sequence. So our first would be carrier file, and then it would be malicious file, and last would be encoded file. And that's it. This will result in output file which will contain our embedded code. But let's just check for an error. So error equals to, we can say that if error is not equal to nil, we can simply print out the error fmt.println or print error, and then we can exit our program here, os.exit 1. Else we can show a message that file has been successfully encoded. Fully encoded. Clear this out. Oops, CLS. Okay, so now we will run this program and you will see that a new file will be created. So I'm going to run it as go run main.go, and you will see that it will take some time. And now it says that file has been successfully encoded. If you go over there, you can see that there is an encoded test file. If you double click it, you can see that it is the same file and there is no difference between these two files. This is the test file, and okay, so can I split vertically? Okay, yeah, so you can see that this is the test file and then this is the encoded. There is no difference between these two files. But if I go to the Explorer, you can see that the encoded text has a huge size, which is 2.6 MB, while the original file was just 538 KB. If I check it here, you can see that it is 2.6 MB, which means that now this data has been encoded. In next lecture, we will learn how to decode this data. Okay, so in our previous program we learned how to encode our malicious file into the image file. In this section we'll try to decode the same file using the embedded our encoded file. So the first thing we need is we need to define the names of the files. So we can say that encoded file equals to, and now this file will be the one that contains our malicious files. So it would be called encoded underscore test dot jpeg, and the last thing we need is a result file. So result file, and this file will be a malicious code or malicious file. So let's call it malicious.exe, and the rest is pretty simple. You just need to call the stack dot decode by file names, and then you need to provide the file. So the first thing you require is the carrier file, which would be encoded file, and the result file, and this will return an error. Error equals to, and then you can check if error is not equal to nil, fmt.println can't decode file, or else fmt.println successfully decoded file. Clear. Now we will run this program. Go run decode.go, and it will take some time, and now it says that successfully decoded file. If you go over there, you can see that there is a malicious.exe. Oops. And if you go to the show folder, you will see that it has the same size as our original malicious file. So in this way you can decode these files. So that's it for steganography. Okay, so in this section we are going to focus on how we can protect ourselves from hackers. There are a lot of ways in which you can protect or make sure that your online presence is safe. Let's start with protecting yourself. So how to protect ourselves? The first thing you need to do is you need to make sure that whenever you are using a public Wi-Fi, you don't access on any website that is sensitive. For example, website that contains your financial data or something like that, or you don't access your bitcoins, anything that is sensitive. Never use it on over a public Wi-Fi, because public Wi-Fi is very unsecure and hackers can easily bypass it using ARP spoof or DNS spoofing or something like that. So never use a public Wi-Fi for your sensitive communication. You can use it for maybe bare purposes, but then again focus on, if you must do it, make sure that you use some kind of encryption methods. For example, a VPN that encrypts all your traffic over this network. Second thing you need to do is never give extra permissions to something that doesn't need it. So if software, website or app requires permissions that are not very reasonable, you should never allow it. Most of the time they ask for permissions, and whenever, for example, if you are installing an app on your phone or something like that, it will show us an option for you to select which permissions it requires. Always read these permissions. For example, a text messaging app should not access your, for example, GPS location or something like that. So always choose apps that comes from trusted sources. For example, choose apps that are developed by companies that have certain reputation, and always read reviews, because a lot of time, for example, if you are downloading an app from Play Store or something like that, most of the time if they have something suspicious, there will be reviews about it. Updates. Always keep your systems up to date. Windows, Linux, mobile phone, whatever you are using, there will always be updates available if there is any security flaw that is discovered by their team. So most of the time what they try to do is, whenever they find out that there is a certain vulnerability or some flaw that can potentially be exploited by hackers, they've immediately developed a patch for it. So keep your systems updated, and by doing so you can make sure that you are not vulnerable to security flaws. Strong passwords. Always use strong passwords. Don't use password like, for example, 123 or ABC or something like that. These passwords are guessed in minutes, and they can destroy your system immediately. So make sure that whenever you're creating a password, it's unique, and never use the same password twice. And also never store your passwords in browser, for example Chrome or Firefox. If you must, always use some kind of password manager. For example, I use Bitwarden, which is an open source, does all the processing on its local machine, so there is limited applications on the server side. So, and it also encrypts all the traffic. Attachments: never click on any link that is coming from a suspicious source. Even if it's coming from a valid source, make sure that it does not have any suspicious activity behind it. For example, if Facebook asks you for example, they have a security breach or something, and click this link to reset your password or something like that, most of the time this is phishing attack. And if there is a genuine problem, these companies will always be public about it. So never click on any suspicious link or attachment. For example, if your organization has some people and then they send you an email that please check this file or something like that, most of the time it will be a phishing attack. Never share your password with anyone. Even, for example, if you create a password for just one application, still don't share it, because you may sometime use it again unconsciously, and this can mean that the previous person has your password. Encryption: always use encryption to store your sensitive information. For example, if you have a file that contains your financial data or something like that, always use encryption or some kind of password protection method on that, and don't leave your files as it is on your own disk. Even if you know that nobody is going to use your computer, there are still ways that people can access your system or generate a backdoor into your system. So always make sure that your sensitive files are encrypted, even on your local machine. And if you want to upload your data onto the cloud, for example your pictures, images, something like that, make sure that, for example, if you upload your files on Google Drive, make sure that your data is encrypted and don't let it stay on the drive unencrypted. Even though these companies are a lot scared, but still something can happen and your data can get leaked. So always use encryption before uploading your files on the cloud. And deleted files: most of the time what people do is that they plug in a USB and delete something and think that this file has been deleted entirely. This is not the case. What happens is that even if you delete the file, unless you overwrite it, this data will still be present and it can be recovered using different softwares. For example, there are a lot of hard disk recovery softwares that can retrieve your data if it's not overwritten. So just deleting doesn't mean that your files have been deleted. Always try to override this data. Least privilege: always run programs on least privilege. Don't give permissions or access or privileges that the devices don't need. For example, there is no need to run a PDF file with a root privileges. So make sure that you don't give extra privileges, authorization to programs that don't need it. And always use VPNs in order to protect your identity. And if the VPN provides an encrypted communication, this is the best way to go. So these are some of the ways in which you can encrypt yourself or protect yourself while you are present online. So thank you for this course and see you again.